Welcome to solverfy.
We're asked to show that if G is a weighted graph with distinct edge weights, then for every simple circuit of the graph G, the edge of maximum weight in the circuit does not belong to any minimum spanning tree of the graph G. So, to prove this statement, we'll give a proof by contradiction. So let G be a connected undirected weighted graph. And suppose that G has distinct edge weights. And let C be a simple circuit in G. And finally, let T be a minimum spanning tree of G. So now, to engender a contradiction, let E be the edge of maximum weight in C, and we're going to suppose, or I guess not suppose, but for the contradiction, we'll assume that E is in the minimum spanning tree T. So define a new graph T prime as the minimum spanning tree T without this edge E. We have that T prime is then going to be a forest with two connected components. Let F be the edge in the path C minus E. Which is used to move between the two connected components. And we know that this edge F has to exist because E was a circuit. And we also know that F is not an edge in T. This is because if F were in T, then we'd have both E and F in T, and then T would contain a circuit, and it would no longer be a tree. So, We know that E is the edge in C with the maximum weight, and we know that G has distinct edge weights. So it follows that the weight of E is strictly greater than the weight of F. Now define another graph, T double prime, to be our original tree, T, and add to it the edge F, and remove from it the edge E. Well, we have that the weight of T double prime is going to be less than or equal to the weight of T. In fact, it's strictly less than. So it follows that T double prime is a spanning tree with a smaller weight than T. But we had that T was the minimum spanning tree. So it follows that this is a contradiction. And therefore, E cannot belong to T.